Hello, Advent Coders. This is day 2, and I want to show you again what I've been doing for this day. Today is without a live solve. Okay, so I'll just be going through my code and explain what I have done, what my thinking was at the time. Sadly, I was not able to do a live solve today. We had some guests over, and I kind of did it other side, which is okay. Hopefully tomorrow I'll be able to do a live solve. But then I will also again look at somebody else's code and see what can I learn from that code and see if I can improve for the next time, which will be good. So let's start. Today's add-on of code, what was the task? And I think it's best explained on this example over here. You see each row has a different game. And what's happening is there's a bag with colored cubes in it, okay? And in each game, the amount of colored cubes are different, okay? And then what is doing it in each game, the elves are picking out some random cubes out of the bag and showing them to you. So the first time they do that in game 1 is they show you 3 blue and 4 red cubes, and then they put it back. So each semicolon shows you that it's a separate game, okay? Then it is a separate showing within the game. Then the second time they show you something is 1 red, 2 green, and 6 blue, and then they put it back. And then they show you 2 green, and so on. The first task is to just check, hey, which of these games are valid? And a valid game is if there is at most 12 red cubes, at most 13 cubes, and at most 14 cubes ever visible. So we have 20 red cubes here at one time visible. This is not a valid game. And it ends up that in this example, the valid games are 1, 2, and 5. We just sum them together, and that's our answer. For game 2, we want to see what is the minimum amount of colored cubes required in each game for it to be, so that it would be a valid game. So the first one here, we know that we have 6 blues is the maximum amount of blues, or the minimum amount of blues that we need, and 4 reds and 2 greens. And that would make it a valid game. And now to get the solution answer for our task here, we multiply those together. So 4 times 2 times 6 is 48. And then we sum them up with all of the other games. And that is the power of this set. And this is how we do it. So how did I solve this? How did I approach this? Let's look right here. So I have here again the lines that I'm just printing out of my solve. The solve always has my input as a string, including the new lines, etc. And my utils function, as usual, comes in helpful. And I'm sorry if you hear the stuff in the background. This is just my dogs walking about. Yeah, but yeah, here's my lines that I'm getting from here. Then, and I already saw that this is not the best way that I did this, but I've set myself the limit here for the first one. Okay, red, I knew I want 12, green 13, blue 14. Then I know add totals and power. Those are so add totals is the first part and power is for the second part. So this is just for me to keep track of what the code wants me to have, the challenge wants me to have at the very end, right? So what I'm doing is I'm going through every single line because I need to treat every single line as its own game. So I'm stripping off the beginning of the game of the text with left strip, so that I'm just leaving with a number, and then split it with a semicolon so that I have the game number on the left, which I'm making as also as an integer, and then the rest on the right. Now with the rest, what I do is I group them. So I take the groups here, and this is kind of complicating, and I have already seen things to make this easier, and I want to see if I can adapt this. So I want to push this to my repo, and then the improvements I want to push afterwards, just so that people can see the difference. Because again, I like to learn from other people, right? So, but what am I here doing here? This is complicated. So maybe it is easier if we splitting some of this stuff up. The lambda function here. We have this here. Yep. Boom, boom. Okay, so we have a list because the map is just giving us a map function. Okay, so we're mapping something, so that's helpful. What are we mapping? We're mapping some type of lambda function g. Okay, let's keep going. Okay, so lambda function g, in which we then return a tuple. So we just keep going inside, as you can see, right? So it's just kind of getting complicated. Ultimately, we're splitting a few different times. In the very beginning, we are splitting the semicolons because we're wanting to split the different groups with one another. Okay, so this is our input. We have the rest, and we split them by the semicolons to get the different groups. And then what we're doing with it is in the lambda function, because we want, with map, we want to replace every single item in our groups, which is in this case our lines, right? So we have one group. No, sorry. We have one whole set of stuff. We're splitting into groups, and each of those we map with something, and we want to actually replace all of those groups with finer splits. That's what my thinking was here. So I have lambda g, and then I want to get back tuples. And what I do is I map again with another split. So each of those events that are being split by the semicolon, this time I want to split by the comma to say, hey, these are now my individual items. Okay, and then I split it one more time to say, okay, I have the item number and the item text, just to make it easy for me. So if you want to see what exactly this now groups looks like after all of that, I'm just gonna print right here, and you see here as an example all of the things. So I have each of those now split up into the number and what type of cube it is, number, cube, and then this whole instance is one showing, right? And then this instance is another showing. Okay, these are the cubes, and this is the third time the elves are showing you the cubes, and all of that is in one big array of like, hey, this is all one game. So this is all just been split up. It's probably not the best and or the fastest, and I probably again overcomplicated it. But that's why I like these challenges and looking what other people did to make things easier. So I'm gonna undo all of this and keep it as a one-liner. What did I do? Boom, there we go. Now valid, for each line, for each game, I want to say, hey, valid is true, because we have not had any invalids yet. And I also want to count, because I'm doing both parts, part 1, part 2 at the same time, I'm also now counting the fewest numbers. Okay, so as I'm going through each group, I want to count. Okay, so I want to count how many of each do I see. So for each item in group, that is now the second split, I want to say, hey, item 1 is a text. So the count here I want to increase by whatever amount, the integer of that amount is, and the text that belongs to it. Okay, so I'm just counting, hey, how many of each do I see? And I say the fewest I also want to increase in each group, okay? And what I do is I actually say, hey, I want to take the maximum between the fewest that I've already seen and the new number. So if the new number is bigger, hey, replace the fewest of that with a new number. If the old number is bigger, then just keep that. So in that way, I want to make sure that I always have the maximum amount of numbers that I see at any one time. Then, once I have done those two things, I want to go, and this is where I did overkill. All of these 4 lines plus this one line up here, they don't need to be that complicated, and I'm going to show you in a second why. But really, what am I doing? I'm going through the key here and saying, hey, if the limit is smaller or if the count is bigger than the limit, then this is not a valid game, and then I break the group. that could have actually messed things up with my fewest, and it didn't. Keep that in mind, that it actually can mess up with the fewest thing. And I'm really glad it didn't for me. That would have been a bit of a hunt. And then outside of this, I'm gonna check, hey, if it is valid, then I want to add the totals, right? And then also what I want to do for the second part, so add total, adjust the game ID. That's what I'm doing. And for the power, I'm using a func tool reduce. It's just a typical reduce function where I use the lambda function where I have A and B. I take the sum of it. And what I do with the fewest, this dictionary here, and I just take the values out of it. And I multiply them together, and I add it to my power at the very end. And that's it. That's it. That's not that complicated. So the idea, again, is just keeping track of the right things at the right time. And yeah, not overcomplicating it the way that I did it over here. So what am I learning looking at somebody else? So this time I'm looking at Hyperneutrino thing. He does also in Python. And the way that he does it, he splits apparently the two part tasks up in individual ones, like you can see here. But you can see overlaps that some of the stuff is similar. For example, these line 3 and 4 are similar. Then the rest is a tiny bit different. But what am I taking away from here? For example, this line. That's all I needed to do. I didn't need to make it as complicated as saying, hey, compare each key with this dictionary and that dictionary. Just compare it to my hard-coded numbers. That makes it way easier, right? Then what I notice is the way that he strips, he does it all inline without lambda functions and stuff like this and mapping. And this hopefully is going to make it easier. I'm going to see if I can redo this. I really thought, and that might have been because of other languages needing to be that precise, but here it seems like that they can just split them that easily, and I should do that. So yes, that would make things a lot easier for me. Anything else? No, I don't think so. Let me just check one last time. Yeah, he does the same thing. He maxes between what is already in there and what is not. And this is one thing, he's doing a lot shorter names, TM, GS, and all of this, which is great if you want to speed code, and that's all he is about, right? 100% speed coding. Readability obviously starts to make it a tiny more difficult. So you always want to have this trade-off between, hey, read it really fast or write it really fast, right? So, but yeah, these are the two things that I'm taking away from here. Again, take this opportunity to learn and to improve in your language as much as you can. And this is for me. If I have another thing, if I wanted to update with the code, you'll see it now. Otherwise, I'm going to say Auf Wiedersehen.